Hello there and welcome to this course on clustering analysis with Python. My name is Valentine and I'll be your instructor. In this course, we are going to be following the following structure. So we are going to get started with the learning outcomes, then later get to learn about what clustering is. We also get to learn about important concepts related to clustering, why we apply those concepts, as well as when do we apply them. After that, we'll go through a reading, which is just going to generally be a document that we have curated that will contain the concepts that we will have gone through in an in-depth way. And the idea is that you should get a deeper understanding about those clustering concepts. And then after that reading, you will complete a quiz to just check your understanding of those concepts. After that, we'll go to our practice session, and that will entail applying those clustering analysis concepts with the Python language. So we're going to implement those concepts using a real-world data set so that we have a hands-on approach when it comes to working with those skills. So that is going to happen in the practice session, and we will share this. We will share this notebook that you see on your screen, which will contain the curated examples for both actually the common types of clustering analysis techniques. We'll also provide a solution. So we'll have in the practice notebook, there will be some challenges that you'll get to work on. And we also have provided some solutions or sample solutions to those challenges so that you can assess your understanding of those concepts, which you'll find also that we've shared. Aside from that, once you have gone through the practice session, once we have gone through, I'll take you through that. As part of the next steps, we'll provide you with a project that you can work on that will help you to implement the concepts that you have learned in the practice session. So we will provide this particular project, which will just be a real life project that you can be able to use to just be able to practice more those skills. In addition, aside from this project, we'll also provide a guiding notebook to the project that will give you a good idea of the approach that you can take. Instead of starting from scratch, we'll just give you a notebook that will contain already curated curated material code that you can still use to just understand your data set before later performing the data or clustering analysis techniques with Python. Lastly, we'll provide a solution notebook that will just give you a sample solution of the actual project to just also give you an idea of how you would have alternatively gone about the project. So generally, that is the approach that we're going to be taking for the next 1 to 2 hours. Can't wait to take you through this course. So let's get started. So starting off, what is clustering analysis? So actually, we'll start with the learning outcomes. So by the end of this particular learning experience, we will be expected to have achieved these learning outcomes. So we should be able to describe the concept of clustering analysis in supervised learning. We should also be able to differentiate between clustering analysis methods, be able to recognize when to apply different clustering analysis methods, be able to apply the k-means clustering methods, as well as in solving unsupervised learning problems, and also be able to apply the hierarchical clustering method in solving unsupervised learning methods and problems. So you'll note that we have another term that we might not be familiar, that's unsupervised, and this refers to that type of machine learning that does not rely on human intervention when it comes to preparing those models. So we do not train the models that we're going to be working with when we are working with unsupervised learning techniques. So in the case of k-means as well as hierarchical, no training will be involved. We'll be using these two types of methods to be able to classify or assign points to different categories. And actually, that is actually what clustering analysis entails, which we'll actually learn in a few. So yeah, so those are the learning outcomes by the end of today. Those you should be expected to have achieved those learning outcomes. So clustering analysis generally is a type of analysis that groups data into objects based on information found in the data. So it could be that you might have a data set and you wanted to group the records in that data set into different categories. Possibly you would have two different categories and you'd want to group the records to either categories. Then you can use clustering analysis, this type of analysis, to be able to understand the patterns that the data have and use those patterns and key insights from those patterns to be able to assign the data or the records to the respective categories. So when we are working with clustering analysis, we're generally grouping just different data or just records into categories or classes, or and yeah, so that's generally it. On the other hand, in some other cases, if you were to compare clustering analysis with something like supervised, not even supervised, but if you were to compare it with classification is a type of it's called supervised learning supervised learning. So it's a type of machine learning. Well, classification just refers to that process that entails creating a machine learning model that helps you to group records, but upon having trained the model that you're going to be using. So in classification, you have different kinds of machine learning models, which we call, or we term them as classifiers. And a few examples would be a decision tree classifier or KNN classifier, or a logistic regression classifier. And these models, you would need to train them based on from just training data or historical data to be able to make those decisions on where new records should be assigned or what categories they need to be assigned to. But on this other side of clustering analysis, you would not have any training process happening. Instead, you have this this particular method that or technique that just helps you to be able to just classify a record just based on what it has learned generally from the or the patterns it found about that particular record. So the goal of clustering, therefore, is to group similar data points together based on their inherent characteristics, with the objective of uncovering hidden patterns or structures within data. There are various applications of clustering analysis. So in market research, where you're trying to understand customers, you might want to group data in relation to customers, so that you end up possibly with groups of high value customers as well as low value customers, or customers that tend to spend a lot more than others. So you could actually apply clustering analysis in such situations as pattern recognition, data analysis, as well as image processing, where you're also trying also to classify images as well. So generally, those are applications. There are of course many others, but those are just some common applications of clustering analysis. When it comes to just fundamental concepts that you're going to be learning about clustering, the scalability, so the ability to be able to apply these techniques as data grows, ability to deal with different kinds of attributes, so you can have data that has different characteristics, maybe data that's normally distributed, data that is that has outliers, data that has missing values, etc., then while performing clustering analysis, it's an important concept to consider. High dimensionality just refers to having a data set that has quite a large number of variables or columns with respect to the number of records in that data set itself. Noisy data, I've already talked about that, as well as interpretability, how you're able to interpret the final outcome. So that is also a key consideration. On the right hand side of your screen, you will see an image which just displays, it shows more about what is called the CRISP DM methodology, where we tend to use this methodology to work on projects. So if you were working on a data analytics or data science project, we would normally start by first understanding the research problem during the business understanding phase, then continue to data understanding phase, where we are trying to explore data, then prepare data, then perform machine learning tasks, or perform classification, clustering analysis tasks, then evaluate our end result to check whether actually a solution that we have developed answers the research questions, the research question. If it doesn't, then we go back and start all that process all over again. But if it doesn't, we start, we go back to a business understanding phase, and we try to figure out what would actually work best for a solution, and then walk through this other stages again. But if our solution actually satisfies our research problem, then we can just deploy or present that to various stakeholders. So that's just a quick example of that. When it comes to the different types of techniques that we can use, or the different types of clustering analysis techniques that we can apply in order to assign categories to data. So we have what is called centroid-based clustering technique, which just involves the grouping of data into what are called clusters, and those clusters usually have a central point, which is called a centroid. So when you want to group maybe a record, you would try to identify where how close that record is to the centroid, or the central point of the existing clusters. And if it's closer to one particular centroid, then that particular record would be assigned to the group that has that centroid as the central point. And examples of algorithms that tend to use this approach would be the k-means clustering algorithm, or the k-medoids clustering algorithm. So these are just approaches that we can use. That's the first one. It's the most common one, the most interpretable one in many cases. There's hierarchical clustering, which is another technique that we can use to assign categories to data. How this type of technique works, clustering technique works, is that it creates a hierarchy of clusters where the data points are grouped into just nested clusters based on their similarity. So you can think of it, so it works in two ways. You can think of it as when you have a data set, you try to identify which of the points that you have in the data set, or which of the records in the data set are closer to each other. And then once you have identified that, you would group those records together first. Then again, once you have done that, you move on to the next step, which would be to now group which group of those grouped points are much more closer to each other. And the idea is to continue that whole process, and what would be the outcome of that would be more of like a tree structure, where you have at the very top the entire data set, but if you go downwards, you actually get to a point where you just generally have just individual data points. So yeah, hierarchical clustering can follow that format, where you start from bottom, where you start with just individual records and you group those individual records that are closer to each other, then continue. It's usually called bottom up. Or you could also have top bottom approach, where you start with an entire data set, then you split it into 2, then you split it into 4, then you split it into 8, based on how close those particular points are to each other, or group of points are to each other. So that's usually hierarchical clustering. Density-based clustering, on the other hand, is an approach that we would use, and this would consider what is called just density. So you would identify clusters or groups of data points as regions of high data point density. So each point would be grouped according to its density. So there could be points which have high density, while there are others which would have lower density. And this particular technique is quite useful when we have irregularly shaped clusters, especially when we have lots of outliers in a data set. Yeah, so generally those are the 3 types of clustering analysis techniques that we would apply, but the most common one is the centroid-based clustering that you would find in many cases, and more so using the k-means algorithm, which we'll get to learn. Why is clustering analysis important? So now we're trying to wrap up. Why you'd want to perform clustering analysis. One would be if you want to explore your data. So clustering allows us to reveal underlying structure in data by grouping just similar points together, which can just lead to insights about the nature of data. Possibly some group of data might have some patterns, some similar patterns, or some relationships, other relationships between those data points. So you're able to get that out of clustering analysis. You could also perform pattern recognition. So you're able to also uncover patterns and trends that may not be immediately apparent. So if you look at a data set, especially one that has lots of data points, you may not necessarily be able to determine what patterns are hidden within, or trends they are within the data set. So if you want to be able to identify those patterns or trends, clustering analysis can be one of those valuable techniques. Anomaly detection. So by identifying clusters of normal behavior, you can be able to you can be able to identify clusters of normal behavior, as well as clusters which seem to be far away from the rest. So in a data set, assuming that you had you wanted to identify anomalies, you might realize that if you perform clustering and you expect to have 2 different groups, one group of outliers and another one without, then a clustering analysis would allow you to be able to group those records, which could have maybe errors or some just unusual values grouped together at the very end. When do we apply clustering analysis? Again, I think some of the why reasons might also fall into this category, such as anomaly detection, when we want to identify which of the data points are actually anomalies. That's something that we could do. Alternatively, we could also want to apply clustering when we want to perform customer segmentation. So if you want to identify distinct customer segments based maybe on demographics, behavioral preferences, or even other variables that you have in the data sets. And the idea is that you should, once you've been able to perform these or identify these distinct customer segments, you can then maybe tailor marketing strategies or product recommendations for those particular segments. Lastly, you might want to apply clustering analysis when you want to perform market research and targeting. And the idea is to analyze maybe survey data, again, still could be market research data, to identify market segments and also consumer groups in an effort to optimize advertising and marketing campaigns Yeah, so generally those are just a few reasons why and when you would want to apply clustering analysis. So yeah, so the next thing that we're going to do is to go through the reading that will contain just more details about what we have talked about. The idea is to go through the reading that you will have shared, and then once you've gone through the reading for about 10 minutes, you can go through this particular quiz, which should just assess your understanding of those concepts, or the reading generally. And once you're done, then we'll continue to the practice notebook. But before we continue, I would also want to make it clear that the resources that you will find or that you find that we are sharing may not necessarily be available for free. So if you're coming in from a different platform, maybe aside from YouTube, where sometimes we post such courses, you will find probably it's because of the platform that you have already signed up for, you will have those resources available. But if you come from, from YouTube, you will find that you need to become an after-work member to be able to access those resources. But if you don't want to become an after-work member, then you can just bear with us and continue to the next section for the practice work, where we will cover the clustering analysis concepts in practice. And we've also provided a sample practice notebook to just give you a walkthrough of the same. But if you want the challenges as well as to get to work on the project, then you can become an after-work member and have all the resources needed. So yeah, so let's do that. Let's take about 10 minutes to go through the reading and the quiz. Then when we come back, we'll go through the practice work. All right, so the next thing that we are going to go through is the practice notebook. And this will just entail putting into practice those concepts that we have covered so far. So click on the practice notebook or the sample notebook if you just want to go through the examples. And then it should take you to such a page. The first thing that we need to do is to save a copy of this notebook in Drive. So this is a master copy. So we need to save a copy that we can be able to edit and save on Google Drive. So we need to go to File, then save a copy in Drive. And once we have done that, so just go to File, save a copy in Drive, and it should open in a new tab. And then you can close this old copy, then rename the new copy at the very top to your own copy to be saved in Google Drive. Once you have done that, we will need to connect this notebook to Google servers by clicking on Connect. So this notebook is hosted on Google Drive, just like any other Google Doc document, Google Drive document. And Google Drive also has an application called Google Colab that allows us to work with notebooks. And notebooks generally would be those documents that data analysts or data scientists would use to showcase their work. And in a notebook, you have what are called cells. Like, well, these are just containers that contain content, whether it's code or text. But we have code cells as well as text cells in our notebook. So the first thing that we do is to connect. Once it has connected, you should see a check sign or check at the very top. Then we can now move on to our work. So let's expand this by clicking on this arrow and then going to prerequisites. We first need to import the libraries that we need. So we need pandas, numpy, and matplotlib. So let's run that. These are just libraries that we can use to perform various tasks. So pandas, it's a library specifically for data manipulation, numpy for performing scientific computations, and matplotlib for performing visualization or creating just basic plots. And we also have just courses on these separately, these libraries separately. So let's go now to the examples. We'll go through the examples and then see how we can work with how we can be able to apply the same in the challenges that we'll get. All right, starting off, in this example, we'll use the k-means algorithm to create 3 clusters from our given data set. This algorithm will partition our data into k clusters such that data points in the same cluster are similar and data points in different clusters are far away. So the value of k would be the number of clusters we would want. So with k-means algorithm, we need to identify how many number of clusters that we want to be created in a data set. So in our case, we might decide maybe to set it to 2 or 3 for 2 different groups or clusters that we want. So we also import the clustering algorithms that we're going to use. K-means clustering algorithm, as well as the hierarchical clustering algorithm, which is agglomerative clustering. So we import by running that. We'll also load our data set in the next step. So we import our data set, which is Rio temp df. We just import it and preview the first 5 records, which we can see. We have just year, then we have the months up until December, then we have some other information, some other variables. So what we want generally is to group all these records into different categories. But before we do that, let's just understand our data set, explore it. So we just have a good idea of what it has, the kind of data it has. We won't perform just extensive data exploration or technique or cleaning or preparation or statistical data analysis techniques, because our focus for this course is just to apply clustering analysis. So we'll skip that, but in the future, that is something that you could look into. So the next thing would be now to select the data that we want to work with. So what we want to work with generally is actually the entire data set. So how we can be able to select all the values in the entire data set is using the illoc method. So we first of all define the data frame or the table that we want to work with, which is Rio temp df. And then illoc method, we apply it as shown. We want to select all the records and also all the columns, and then dot values, now their values, and save the result of all the values inside the x variable. And we can be able to now to do something about it. So what we will have here will be just a matrix of just values that we have for all those records. So like for instance, we have an array, and this array has just a list of lists. We have a list of lists inside. We have, this is the first record, 1973, 2416, 1973, 2416. I think that just gives you a good idea, etc. So we can then perform what is called normalization to just ensure that our clusters are not affected, or the algorithm that we're going to use for clustering is not affected by the scale or values, because some values like these ones, they are fairly okay. They are around the range of 20s, but we have one that's around the thousands. That's the year. So we can scale the entire data set instead, just ensuring that all our values are within one particular limit. That's between 0 and 1. When we perform normalization, that's what we do. Once we have done that, we now go to applying our clustering algorithms, or creating clusters. So first of all, what we are going to do, we're going to create a k-means object, or which is just what we would get from the class that we had imported. So we have k-means here. That's what we are referencing in our situation. By object, I mean that in Python, we normally work with what is called object-oriented programming, which is generally a way of organizing your code into what are called objects and classes. Classes are just more like templates, and objects are just more like copies of those templates. So we normally organize code in the form of just maybe just classes, and then when we want to use that code, we just create a copy of it, which is more of like creating an object of that class. So that's what we are doing here. We are setting k-means to have 3 clusters. We want to create 3 different we want to have 3 clusters. So we want all our records to be grouped into 3 different clusters, and we set random state to 0 so that we can be able to reproduce the results of our work later. Otherwise, we will be getting just different outcomes afterwards. Then we pass our data to the object or the clusterer. We can call it the clusterer. Let's run that. Once we have done that, we can be able to just preview just those different records. By this, we have already assigned our records to different categories. So we can be able to see those categories as shown. So we have 0, there's 1, there's 2. So the first record has been assigned to a cluster called 0, another one. So all these records that you see here and the other zeros have been assigned to cluster 0. So we have a few records, quite a number of records assigned to 0, and some others into 1 and others into 2. So we can be able to also return the cluster that each data point belongs to by simply just using the predict method to be able to do that. And then we can display now the so here we just created a new variable and we stored the we assigned each record now the labels that we had here, and then we preview our records. So we just sampled a few of them from, like, index 1. This record was assigned to cluster group 0, etc. So, but we had this particular record which looks different, looks more like an outlier record, was assigned to cluster 1, etc. But we can always sample as many as we can. But we always, when we use the sample method, our function will always get just different number of records because we're performing random sampling of the entire data set. The next thing, to preview the records in our first cluster. So if you want to just preview the ones that have 0, so we can say we can use this method. So we first of all reference the entire data frame, then we use square brackets, then we specify the column that we want to check for the values, and we check whether 0 is in that particular column, and this entire piece of code will return those records in that cluster, and we can preview the first 5, and we can see these are the first 5 records in that first cluster. The same case for the second cluster, but here we changed that to 1. So this should contain those outlier records which have just just different kinds of values. As you can see here, the values are just big, and you'll notice that they're actually 4 records and we had asked for 5, so it means actually we don't have more than 5 records. We only have 4 records that have these sorts of values. And the third cluster is in 2, would be this other one. It's almost closer to the second one, only that in the second one we have more 999s than in this other cluster. So yeah, so generally that is how we can be able to perform clustering. So we have been able to classify or assign categories to those records, and sometimes you might even be able to use such a data set, a final data set that contains all the that contains the classes as part of a training data set. Something to note is that we can also determine whether the number of clusters, now the number of clusters, which is in our case was 3, whether it's the best suited one for this case. So we can use 2 methods. There's one method to determine, actually there are many more methods, but these are the most popular ones. There's the elbow method that allows us to be able to determine whether we actually were able to, or actually it helps us to identify the number of clusters that work best for this particular data set. So we can implement it as shown. So we first define an empty list where we can store what are called errors, which are just squared errors that we would calculate, and then we use now the k-means cluster to find those errors and be able to append them in the error list. And then once we have been able to do that, we can be able to plot a visualization which would show us just which would give us generally something like this. you can ignore this future warning error. Just means that we need to change something in our code, but it will still work. So how the elbow method works, once you have implemented it, you should you should try to see where there is some sort of change, not a smooth change of direction of the graph. So in our case, at the number of clusters 2, there was a sudden change. It's not as smooth as you would find in other points, like at 4, 6, even at 5. So it means that the number of clusters, optimal number of clusters for this data set is actually 2, not 3 as we had. So I would think that these records would actually be grouped together with these records. But again, that is something that you could determine with just domain expertise. So that's one approach. The second approach would be to perform what is called silhouette analysis, where you tend to study the separation distance between resulting clusters, how they are from each, how far apart they are from each other. And you would actually create what is called a silhouette plot to display how close each point is, how close it is from one cluster to the other clusters. So we almost use a similar kind of an approach. The only thing in this, as in the elbow approach, the only thing is that in this situation, we are going to be calculating the distance between the resulting clusters for each value of k. So let's run that. And then we plot the silhouette plot, which you can see in our situation we have here. But now for how to interpret the silhouette plot, we normally would consider the number of clusters that's at the very top, the one that has the highest value of silhouette coefficient, as the value to use for the optimal number of clusters. So in our case, 2 would actually be the one that we would use because it has the highest silhouette coefficient value. So that is how we would be able to interpret that. So if you have the highest value, then you can consider that as the one that we can use for as what we can use generally. So yeah, so that's just generally that's the first method. So of performing clustering analysis. That's the k-means clustering analysis method. And then we can use silhouette analysis or the elbow method to just check on the optimal number of clusters to use for the data set. And once you have done that, you've determined that, you can then go through the same step again, only that in this case, we would change the value of k-means, the k parameter in k-means to be 3. And you can even still just say k equals, it doesn't usually make a difference because k-means is a parameter. If you scroll down, you will see that should be able to find that as well, somewhere there. So, or just n clusters, actually not k, but n underscore cluster is actually what you would use. All right, I think that's good. The next method we are going to learn that implements hierarchical clustering is agglomerative clustering. So again, I had mentioned to you this earlier, there are 2 different approaches. There's agglomerative clustering, that's bottom up, and divisive, top down, where you start with the entire data set and you split it. And the idea, you just have a tree that represents just the separation of clusters. So starting off, we're still going to use the same data set that we had used, the X data set, the one that we had retrieved here. So just going back to data modeling. So this is the data set that we're going to use for this other case, only that we are going to, once we have done that, once we have gotten it, we're also going to, so this is actually another way we can also do something like this. This is another way we could also write it. This is a short form of this. So we could still also create our agglomerative clustering object and then apply this method, fit method as such. So this is an alternative method, but this is a shortcut that we had. So we could run that. to create the agglomerative cluster that we can use to perform analysis. Then we display the label. So we have now performed agglomerative clustering, and this is what we have. And we only have two different values. And you'll note that for agglomerative clustering, we don't define the number or the value of k. Automatically, agglomerative clustering just is able to identify those, is able to classify those records accordingly. So we have zeros and ones, which are different classes. We can be able to create that column in that data set and preview now that data set as shown. You can see 34, which has quite an outlier values, should move on to the right. The agglomerative so we have two k-means and agglomerative cluster algorithm. So it actually also classified this record as a 1. So, but for this other one, which didn't have more of 999s, it was classified as 0. So for agglomerative clustering, we can be able to also determine the correct or the optimal number of clusters, just like we did for k-means with using the elbow and silhouette method. For agglomerative, we can use what is called a dendrogram, which just basically is a visualization that helps to display a tree of clusters, and we can be able to interpret a result from that. So we are going to create a dendrogram, which you would see here. And generally, what would happen here is just we can be able to interpret this as just how we were able to build or perform actually apply hierarchical clustering, where at the very bottom we have, let's say, record 12 and 30, which are much closer together, which were grouped together, then 20 and 30, then 34 and that group of records, etc. But how we can be able to determine the optimal number of clusters from such a graph is to generally to look at which of the lines that we have, the horizontal lines, actually are have the longest distance vertically. So in our case over here, you could see that there are two lines. That's these two lines that we see here, which actually have the longest distances. So in such a situation, we can then decide to draw some sort of imaginary line. So if you were to draw a line from this side to this other side, that line would cut these two lines twice. In some other situations, maybe you might have, instead of these two lines, you could have this particular, these two lines over here come to the very top. And in such a situation, if you were to draw a line, or because those ones would be the longest ones, including this other one, then in such a situation, you'd have 3 clusters. But in our situation now, we have 2 clusters, which, it would be representative of the optimal number of clusters. So if you were to draw a horizontal line that passes through the longest distance without a horizontal line, then you would be able to cut this blue line twice. Maybe I think you could always just try and understand it. So if you have 2 long lines and draw just a horizontal line, then that horizontal line would cut now those 2 lines twice. Then in such a situation, you would have 2 optimal clusters. If you had 3, same case, you had 4, etc. Right, so that's it. At this particular point, work on those challenges that we've provided, one on clustering and another one on agglomerative, one on implementing k-means clustering. Actually, you will be in a position to apply both in both challenges. So you will work on challenge 1 and 2, and then once you're done, you can just check your solutions on how you're able to implement the same through this particular Sambo solution notebook that you'll find. Once you're done, the next thing that you're going to do is to go through this project. So we have curated this project that will allow you to put into practice those concepts, as well as provide recommendations, actually generally to just work on a research problem, a real life problem. And you will go through this document, which will just give you some good idea of what to expect. And you can use this guiding notebook that we have provided from the very start. You can start from the very top to understand what is required of you. You can even import your own data set, the one that we have shared in this particular document, or upload it using the file upload feature, etc. So once you have uploaded it, then you can go through just the initial steps. Some of the concepts that you see here, we have actually implemented them in other workshops, such as Matplotlib, data visualization with Matplotlib, and data visualization with Seaborn. You could always consider going through those courses first. But again, just try and go through all of it, key in some few important information that you might notice, then work on the data modeling bit, and then provide recommendations at the very end. Once you're done, you can check your sample solution notebook that we will also have shared to just see how you'd have alternatively gone about the solution. And that's it. That's it with regards to this course on clustering analysis. The next steps, once you've finished even working on the project, would be to go through now some advanced workshops, maybe in machine learning, maybe looking into regression or classification or ensemble learning, or even now going into working with textual data. So getting started with text analysis might also be some good workshop for you to be able to continue becoming or continue acquiring skills that might be important in your line of work, maybe as a data analyst or data scientist or machine learning engineer. All right, all the best in your learning journey, and hopefully we'll get to interact more. If you have any questions, feel free to ask in the comment section of whatever platform or whatever platform that you're taking this course in. All the best in your learning journey, and see you in the next course.